All right, so in this lesson, we're going to be talking about complex numbers. What are complex numbers? We're going to be finding the absolute value of complex numbers. We're going to be graphing complex numbers. So we're going to be working with them. There is a real part and an imaginary part to a complex number. So let's go ahead and dive on in here and see what these are. Here's where complex numbers come about. In the past, we would solve equations like number 1 here, and we would actually end up with something that wouldn't really be a true statement, or it wouldn't have a solution. We would subtract 25 from both sides here, and so here we would subtract 25 as well, and we would end up with x squared equals negative 25. And so then we would take the square root of both sides because we want to undo the square root sign. We'd have x equals, and then we would run into a problem. And the problem would be that we can't take the square root of a negative number. Well, now we can take the square root of a negative number. This is going to be plus or minus 5, but imaginary. One of the things that you should put in your notes right now is that, let me change colors so you can see this a little bit better, is that if I have the square root of negative 1, that is equal to the number I. And so when I simplify the square root of negative 25, that's the same thing as the square root of 25 times the square root of negative 1, because 25 times negative 1 is negative 25. We know that the square root of negative 1 is I, and we know that the square root of 25 is 5. And so this is going to be just plus or minus 5i, and the I just stands for imaginary. And so let's go ahead and simplify 2 and 3 just to get familiar with this. The square root of 12 we can write as the square root of negative 1 times the square root of 4 times the square root of 3. And so let me clean that up a little bit. All right, so we have the square root of negative 1 is I. We know that the square root of 4 is 2. And I don't know what the square root of 3 is, so that will stay inside the radical. So the square root of negative 12 is the same thing as 2i radical 3. If I do the same thing with the square root of 72, I know that the square root of 72, that's the same thing as 36 times 2 times negative 1. And the reason I picked 36 is because that is a perfect square. The square root of 36 is just 6. The square root of negative 1 is I, and the square root of negative 2 I don't know. And so if I simplified the square root of negative 72, I would get 6i radical 2. Now we could do that other ways as well. I could have done negative 8 times 9, and then the square root of negative 8 would be like the square root of 4 times the square root of 2 times the square root of negative 1. And then the square root of 4, well, that's 2. The square root of 9 is 3. The square root of negative 1 is I, and the square root of 2, I don't know. And so 2 times 3 would be 6i radical 2. And I would get the same thing as I did before. Normally when we do this, we always have the square root last, because if I put the square root of 2 and then I, sometimes it's hard to determine whether that I is underneath the square root or not. So the square root always goes last, and the actual number goes first. So here's a quick explanation of what complex numbers are. Long time ago, you started with just natural numbers. Natural numbers are in our very most basic set. They're 1, 2, 3, 4, 5, 6, and so on. The square root of 4 is a natural number because it's 2. We have 1 and 5 and 3, and all of those positive whole numbers are what we call natural numbers. Well, then we added the number 0. That's kind of a different concept. It makes our natural numbers whole numbers. So whole numbers include all of the natural numbers plus 0. And what we're doing is we're expanding this to be bigger and bigger, a bigger and bigger set of values. Then we started talking about integers. Integers include all of the natural numbers, all of the whole numbers, but also the negative whole numbers. So we have negative 1, negative 3, negative 99. All of those are integers. Then we have rational numbers. And rational numbers include things that are ratios, like 1/3 or 0.3 repeating, or 4/5, or 0.6 is 6/10, or 1/2. Even 0.8 repeating, that's the same thing as 8/9, which is a rational number. Anything we can write as a ratio. Notice 3, which is a natural number, we can also write as a ratio, which is 3/1. So all of the natural numbers, whole numbers, integers, they're all rational numbers. So then we have things that are not rational numbers, things we can't write as a ratio. So that would be like pi, or the letter e, or the square root of 2 we can't write as a fraction. Square root of 3 we can't write as a fraction. Square root of 5 we can't write. Square root of 6 we can't. Square root of 7 we can't. Square root of 8 we can't. So all of those radicals are irrational numbers, and we really don't know what they are. They're like pi. They're a decimal that goes on forever and ever and ever but never stops. We really don't know what the square root of 3 is, or the square root of 6 is, or the square root of 5 is, or what pi is. Those are all irrational numbers. Then there are numbers that are complex numbers. Complex numbers include all of the natural numbers, whole numbers, integers, rational numbers, irrational numbers. But complex numbers have an imaginary component to it. They're in this form, a plus bi. In other words, they have a real component, but they also have an imaginary component. So it might look something like this: 4 plus 3i, -2 minus 2i. -1 is the same thing as 0 plus I. And so that's a complex number. The number 3 is a complex number. It would just be 0i plus 3. Or maybe I should write it as 0, or as 3 plus 0i, because we usually have the real component first and then the imaginary component. So that's a quick look at the number system. Let's go ahead and see if we can simplify these complex numbers so that they're in form a plus bi. So I'm going to start by simplifying the square root of 18. That's the same thing as 9 times 2 times -1. So if I simplify that, it is going to be 3, because the square root of 9 is 3, the square root of -1 is I, and the square root of 2 I don't know, plus 13. And so if I write it in a plus bi form, it's going to be 13 plus 3i radical 2. That's a radical 2 there. If I do the same thing with number 5, I can write that as 9 times 3 times -1. So I'm going to list the 5 first, but then it's going to be the square root of 9 is 3, the square root of -1 is I, and then I have the square root of 3. And so if I simplify those and put those in complex form, it's going to be 5 plus 3i radical 3, and it has a real component and it has an imaginary component. Same thing with number 4, as a real component and an imaginary component. So let's do some things with these numbers. Let's first go ahead and graph these so that we can find the absolute value of complex numbers. So first of all, the absolute value means how far it is from 0. So distance from 0. And so when I graph something like 3 minus 4i, what I'm going to do is go 3 in the real direction and -4 in the imaginary direction. So on this axis, I have a real axis and I have an imaginary axis. So the real axis, I'm at 3. So I'm going to go over here 1, 2, 3. And then in the imaginary direction, I'm at -4. So this would be like 1i, 2i, 3i, 4i, -1i, -2i, -3i, -4i. So I'm at 3, -4i, which is this point right here. So the question is, how far away is that from 0? And so I'm going to draw this triangle here. This distance is 3 in the real direction. This distance is 4 in the imaginary direction, and I have to find x. So if you remember the Pythagorean theorem, we know that 3 squared plus 4 squared equals x squared. So that's 9 plus 16 equals x squared. 9 plus 16 is 25 equals x squared. And if I square root both sides, x is 5, which means the absolute value of 3 minus 4i is 5, because it's 5 units away from 0. Let's find this one. What is the absolute value of -5 plus 12i? Well, it might be helpful to understand what's going on to graph this. In the real direction, I'm at -5. 1, 2, 3, 4, 5. And in the imaginary direction, I'm going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm -5 and 12. That's this point right here. I want to know, what is that distance? Well, if I make this triangle here, this distance here is 5. This distance here is 12. And so I'm simply going to go 5 squared plus 12 squared equals x squared, because I'm looking for this distance here. And so that's 25 plus 144 equals x squared. 25 plus 144 is 169 equals x squared. And then if I take the square root of 169, I believe that's 13 equals x. And then that's taking the square root of both sides. And so we know that this distance here is 13. The square root of, or the absolute value of -5 plus 12i is 13. Now I'm guessing that you guys could probably take a look at this and realize that if I got rid of this whole graph, I could still find the absolute value there. All I'm really doing is I'm taking this distance, whether it's positive or negative, it's going to be 5. This distance, I can kind of ignore the I. The distance is 12. And I'm just going to plug those into the Pythagorean theorem. 5 squared plus 12 squared equals x squared. I really did the same thing here. 3 squared plus 4 squared equals x squared. And so that's how we find the absolute value of a complex number, which is its distance from 0. All right, that is our homework assignment. That's what our homework assignment is about. We will discuss questions over this tomorrow in class.